Welcome to the fourth video in this deep dive series on vSphere with Tanzu. Now, I'm feeling really good about this. The little robot guy is giving me the thumbs up, and what that means is that I've successfully configured workload management on the vSphere cluster that we created in video 3. Now, if you've arrived at this video as the first video in this series, welcome. I've actually recommended that you do that if you want to really get a look at the good stuff. And the good stuff, in my opinion, is actually starting to create a namespace, deploying a Kubernetes cluster into it. Everything we've done so far has been just the setup work in order to get to this point here where it really starts to pay off. Now, if you went through this whole thing with me and you got to this point and you didn't get the thumbs up from the little robot, instead you got some error messages saying that that workload management couldn't be enabled on your cluster for some reason, there's a whole bunch of troubleshooting that you can do to figure out why that was. Now, we did do quite a lot of verification steps along the way to make sure that you'd have the best chances of success here. So it might be worth just revisiting some of those steps, such as, for example, making sure that your HA proxy can reach your workload gateway and your front-end gateway, making sure that vCenter can reach the data plane API endpoint on your HA proxy. In fact, let's just dive into HA proxy right now and just go have a look and just see how it's been configured. Okay, it's a good check you can do. Remember I talked about the haproxy.config file. So if we cat that, yeah. So this is, let me just make this slightly bigger so it's easier to read. It's kind of long, isn't it? There we go, just about fitted that on the screen. So you can see here, this has been configured by vSphere. The front end is the IP address, which you can see here, 192.168.20.128. That is the load balanced front end IP of the supervisor cluster. So when we start to log into this as our K8S admin persona, our Kubernetes admin persona, we'll do it on this IP address. And you can see that HA proxy is load balancing this to these two backends here. So that's good. That's one indication that things have been configured correctly. Now, I really think it's worth doing like a full troubleshooting video, looking at where are all the log files, if things go wrong, where do you start looking for why they went wrong? I honestly feel that that's outside of the scope of what I want to do here right now, but I will do that. I promise you now, I will do that. So let's move on and do the very first thing that it's asking us to do here, which is create a namespace. Now before we do that, let's actually just go and look and see what has been created in the vSphere cluster that we built up in episode 3. You can see here these 3 VMs called supervisor control plane VMs. Now these VMs are Kubernetes nodes. This is a Kubernetes cluster that is privileged to vSphere. What that means is that vSphere and this internal, what we call our supervisor Kubernetes cluster, are working hand in hand to provide all of the services and capabilities and integrations that make vSphere with Tanzu what it is. So this is a Kubernetes cluster that you should just consider as part of the vSphere fabric. It's not something that your Kubernetes Cluster Admin will need to interact with in any way other than just to log into it to provision Kubernetes clusters and to administer a couple of things. I'm jumping ahead, but I at least wanted to explain what this is. And as you can see, if you remember from our previous videos, I hypothesized about the IP addresses that these would get, and this is pretty much what I expected. We have each supervisor cluster node has an IP on the management network and an IP in the workload network. And here you'll see 183 and 12 and 182. Now this one is interesting. So you can see this one actually has 2 IP addresses in the management network. Well, why is that? Well, we actually have a floating IP that's allocated in the management network that points to in this particular case, it points to the first node that came up, which was the control plane node that the other ones joined to. That's this IP address here, this 181 address. So the first thing we're going to do is to create a namespace in our workload cluster. So we go to the workload management view, and it very helpfully suggests we create a namespace. Now, what is a namespace? I just want to recap this. Remember in episode 1, I talked about the delegation model between the various personas. The vSphere admin configures their vSphere in such a way that they can delegate some amount of compute to a Kubernetes cluster admin that they can use to stand up Kubernetes clusters. The Kubernetes cluster admin can then delegate responsibility to developers to use some amount of compute within that Kubernetes cluster. So this is the means that the vSphere admin has for delegating some of their compute to a Kubernetes cluster admin or to a team. So you can think of a namespace a little bit like a resource pool with a self-service capability. The K8S admin is going to be logging into this namespace, and it'll be that namespace which will be their point of interaction with vSphere. So let's pick a name for the namespace, and I'm going to call it, well, test cluster. It seems reasonable. And let's select the workload cluster. Okay, so it's created my namespace test cluster. Now, it goes to some trouble to explain what a namespace is and what you can do with it. So let's review what we have here. In this pane, it shows us a general status of our namespace, and importantly, right down here is a link to the CLI tools. Now, the CLI tools are the means by which the Kubernetes Cluster Admin is going to authenticate to this namespace. And so it's going to be important that we give the Kubernetes Cluster Admin this URL, and so I'm going to add it to this as a reminder to myself as the vSphere admin to send that to the Kubernetes Cluster Admin when this is all configured. The next thing we're going to do is give our Kubernetes Cluster Admin access to this namespace, and we're going to do that by granting them permissions. Now, this will illustrate the integration of the Kubernetes experience with vSphere single sign-on, and in order to do that, I need to make sure that my Kubernetes Cluster Admin has a user ID. So let's go here and add our Kubernetes Cluster Admin as a user. Okay. All right, so now I have a user ID. I can go back to workload management, click on my test cluster, add permissions. I'm going to select my this particular single sign-on domain, and I'm going to add my K8S Cluster Admin. Now, I have two roles I can give the admin, a view role and an edit role. Now, since the admin is going to be administering things, I'm going to give them an edit role. All right, so K8S Cluster Admin can edit. Now, storage. Remember we set up our storage policy earlier. Now we can just select this as our storage policy. Now, what does this mean? Well, what this means is that as a vSphere admin, I'm allowing the Kubernetes users to provision things into this storage. Now, I can set limits on that, so I can configure however much or little storage out of that storage policy as I want. But this gets to the heart of the self-service aspect of this delegation model. So when I'm in Kubernetes and I ask what storage classes I have, this will show up as a valid storage class that I can use. Now, if I want to, I can apply limits to the CPU and memory and storage here. I'm not going to do that for now. And this is showing that I have 0 Tanzu Kubernetes clusters running in this namespace. Now, what is a Tanzu Kubernetes cluster? Well, basically, it's an upstream Kubernetes cluster of a version of your choosing. As you saw earlier, we offer a bunch of different versions that has all the para-virtualization and integrations already built into it to take advantage of the integration with vSphere. Now, my job as the vSphere cluster admin is almost done. I'm about to hand over the baton to the Kubernetes cluster admin. They're going to log into this namespace, and then they're going to do all the Kubernetes they want. So I need to make sure before I do that I've given them all the information they need to successfully authenticate. So if you remember, we've already given them the URL they need as their starting point to download the CLI tools. And then we also need to give them the password for the user account that I created for them. And then finally, it's very helpful to give them the root certificate authority for the vCenter so that they don't have annoying error messages when they log in. Now, the way that you get to that is just take the IP address of your vCenter, put it into a new tab, and you'll see down here a link, download trusted root CA certificates. So I'm going to do that. Okay. So I'm going to send that to my Kubernetes Cluster Admin. And if you can imagine now me taking off a virtual vSphere admin hat and putting on a virtual Kubernetes Cluster Admin hat, we'll switch over to that persona, and everything pretty much from here on out is going to be done as the Kubernetes Cluster Admin. Welcome to the Kubernetes Cluster Admin desktop. And what a fun place it appears to be. Now, let's see what we have here. We have an email that I got this morning from my vSphere admin giving me all this information on how I connect to this new feature in vSphere that gives me Kubernetes. Well, we'll be working through this over the next couple minutes. What else do I have? Well, I have the CNCF landscape as my wallpaper. It just reminds me of all the really cool and interesting ways that I can Kubernetes with my Kubernetes. And I have a motivational poster reminding me just how hard my life as a Kubernetes cluster admin potentially is. And, you know, I had a chat with my vSphere admin about this, and they explained to me that actually vSphere and Tanzu deals with so many of these things. All my nodes, for example, on my clusters are going to be automatically highly available thanks to vSphere high availability. The vSphere single sign-on just works seamlessly all the way through from vSphere through to all the clusters I'm going to create. All of the RBAC that I need is just configured out of the box with the permission management. Upgrades are trivial. I just have to edit some YAML and change the version number, and it'll upgrade automatically. Now the vSphere admin is going to be dealing with my backups for me, so that's great. You know, if I really want a strongly isolated team to use a different cluster, well then, you know, I can either create another cluster in this namespace, or if I really want strong isolation, I can ask my vSphere admin to create a whole new namespace and then allocate a new cluster in that. So apparently, a lot of these hard problems are already dealt with, and I'm very excited about that. So let's work through this email I've been given and figure out how to connect. Well, the first thing I can see is some credentials. Now, I'm not sure where I put those in, so let's skip that and move on to making sure I'm on the correct network. I am on the correct network. That's good. Now, as an aside, if you recall, the front-end network is the client network onto which HA proxy allocates all of its load-balanced IPs, and the front-end network is intentionally isolated from the management network and the workload network. So apparently there's some tools I need to download, so let's just start there. If I copy that URL into here, oh, that looks like an error. Okay, that's not good. Oh, seems like some kind of certificate error. Now, what can I do about that? Oh, looks like the vSphere admin has sent me a root certificate authority that might solve this problem for me. So let's copy this into here. Okay, and let's extract it. It's obviously a zip file, so we need to do something with it. I'm on a Mac. Okay, looks like I have. Okay, looks like I have something in here that I need to rename to .crt for whatever reason. Let's add that to my login keychain. There it is, helpfully just called CA. Okay, let's make sure we always trust that and validate that with my fingerprint. Okay, that's turned blue, which I think means it's a good thing. So let's go back to this, refresh. Aha, great. Well, we solved that problem. Great. So we need to apparently download some kind of CLI plugin. It's already detected I'm on the Mac, and reading down here, it seems like this plugin is something to do with logging into the namespace that the vSphere admin told me about. Okay, so let's download this vSphere plugin. Okay, did it download? It did. So let's extract that. All right, so we have kubectl and kubectl-vSphere. Okay, now so let's go to that bin folder. Okay, let's make sure that this is actually kubectl is not executable, so we should make sure that it is. Okay, so let's try that. Yep, that works. Okay, let's copy that to somewhere in my path. So if we copy star user local bin. All right. So I should be able to now type kubectl, and there it is. Great. So informative web page. What it is? What do I do with this? Let's see. Kubectl vSphere login dash dash server. So kubectl vSphere login dash dash server. I'm going off script a little bit here, but it'll be interesting to see what this does. Okay, it's asking for a username. Aha, well, maybe that's where I put in my username. I think it probably is. And then my password. Maybe I got my password wrong. Let's try that again. Okay, all right. So now let's read a little further ahead. Your namespace is called test cluster. All right, well, it looks like there's a context here called test cluster. Maybe that's the namespace. So it says kubectl config use dash context. And then I can do test cluster. Switch to context test cluster. Okay, this is going really well. Now, please, I advise you use a new kubeconfig file. Oh, whoops. I didn't do that. Is that a problem? Okay, let me explain what that means. So kubeconfig is the configuration file for kubectl, which is what we're using here to access the namespace. And the default location is .kubeconfig. So if we look at that, now you'll see in here there's some information in here that appears to have come from the login that we just did. And actually, that's exactly what happened. When we logged into the namespace, it added all of this information into the default kubeconfig file, or wherever the kubeconfig file is configured to be. Now, if your kubeconfig file already has a whole bunch of stuff in it, all of those contexts will appear in the context when you log in to the namespace. And that can get a little bit confusing. It gets particularly confusing if you previously had something that was named something similar and you think that you've connected to it, but you haven't. It's ultimately, it's going to be easier and probably less error prone and less confusing if you keep the kubeconfig separate. So how would I do that? Well, let's imagine that I want to have a kubeconfig in my local folder. So that's my Tanzu folder here. All I would do is I would do export kubeconfig, config equals, and then I can just call it Tanzu kubeconfig. Okay, so now that I've done that, if I log in again and use the same username, which is this one, copy and password. Okay, that has now updated that kubeconfig file. If we do cat Tanzu kubeconfig, yeah, that's updated that kubeconfig file. And so that's kept that separate from any other context that I might have with any other Kubernetes that I might be using. And I think that's worth doing just because, as I say, it just kind of keeps things simpler. So now it's saying that I can use this context called test cluster. So test cluster. And good, I'm now in that context, so I can do what it is that I want. As the Kubernetes Cluster Admin, there's not a lot that I can do in the supervisor cluster. As I mentioned earlier, the supervisor cluster is privileged to vSphere, and it exists as a portal through which the K8S Cluster Admin can create Kubernetes clusters. So actually, the degree to which they can see things and do things is very, very, very limited here. In fact, if I were to do kubectl get namespaces, it shouldn't even allow me to do that. Yeah, it's basically saying, look, you've got access to this one namespace. That's your domain. You don't get to see other people's namespaces. So what we're going to do then is investigate what it is that I can, in fact, do from this portal, right? Well, as a Kubernetes cluster admin, my role is to create Kubernetes clusters. And so the one thing that I can do when I'm logged into Supervisor is create and manage the lifecycle of Kubernetes clusters. And I do that with some YAML called a Tanzu Kubernetes Cluster. And switching back into my role, as the Kubernetes Cluster Admin. Here's a link that someone has given me, that my vSphere admin has given me to the documentation. Maybe I should go and look at the documentation. Okay, so I've already downloaded and installed the CLI tools. Okay, so I've done that. I've already connected the supervisor cluster, so that's good. Now, connecting to a Tanzu Kubernetes cluster. Well, I haven't actually created a Tanzu Kubernetes cluster yet, so it seems like that needs to happen before I can actually think about connecting to one. So let's have a look. Running Tanzu Kubernetes clusters, creating Tanzu Kubernetes clusters. Okay, excellent. So hopefully this will explain exactly what I need to do. So workflow for creating Tanzu Kubernetes clusters. Okay, so this talks about subscribed content library. Okay, the admin mentioned they'd already done that. Install the CLI tools, I've already done that. Connect to the supervisor cluster, I've already done that. So kubectl get virtual machine classes, interesting. Okay, let's have a look and see what that does. Ooh, okay, these look like different kinds of virtual machines that I can use for my Kubernetes cluster nodes. Okay, that's cool. Get Tanzu Kubernetes releases. Interesting. Let's see what that gives me. Interesting. So now we're getting somewhere. This looks like all the different versions of Tanzu Kubernetes clusters that I can create. All right, so construct a YAML file, use the information gleaned. Okay, so I can look at an example YAML file here. Okay. All right, so as a Kubernetes cluster admin, hopefully I'm reasonably familiar with YAML, and I can, construct some YAML. So I'm just going to take this default. Let's just take this default, and I'm going to go to my shell, use my favorite editor. Let's call this simple cluster.yaml. Okay, so we're going to need to edit this. So name, I'm going to call this simple cluster. The namespace. Now the namespace is the namespace that I'm using, which in this case is test cluster. You can see it says supervisor namespace. The version, that's fine. I'll just leave the version at 117. That seems reasonable to me. Control plane nodes. This is the particular the virtual machine class. Now, did I have best effort small? Let's go out and just double check that. Best effort small. Yes, I do have that virtual machine class available to me. Okay. So storage class. I remember something about storage class from here. Please use storage class K8S default storage. All right, so let's do that. Let's go and change that to K8S default storage. All right, K8S default storage. And I've just remembered the command to just delete a whole line. There we go. That's a little more efficient. Great, K8S default storage. Okay, so I'm going to quit that. Now, let's just have a look at some of the more detailed information here to see whether there's anything that I need to know. Okay, seems like I can pick the CNI that's used, and it seems like I can also pick the address ranges for the pods and services. Now, as an aside, the default CNI that comes with Tanzu Kubernetes clusters is Antrea. And Antrea, by default, uses 192.168.0 as its pod CIDR. Now, if that's likely to conflict with anything on your existing network, now remember, we have 192.168.10 for our workload network and 192.168.1 for our management network. It's quite possible that, particularly using a /16, if that's what it defaults to, we're going to end up with some clashes here that are going to cause problems. So to be on the safe side, I'd much rather configure my networking explicitly to use a different subnet for the pods and for the services so that we don't get any kind of issues there. So what I'm going to do is actually copy this out of here, and I might also set the storage class as well. So let's go back to my simple cluster, and I'm going to put Antrea in here because Antrea is is the default. It's also the VMware integrated CNI, so it makes sense. Now for the service siders and the pod siders, I mentioned I'm going to use a different one than is specified here. So I'm going to do 172.16.0.0/16 as my pod sider. And I'm going to do 1096.1.0/24 as my service sider. Now, typically service siders would be bigger than this, but given that this is just a simple cluster, we're just going to run a couple tests in it. That seems perfectly reasonable. Now, in terms of my storage classes, if I do want to create persistent volumes, then I'm going to want to make sure that I specify which storage classes are available. Now, it's basically just the same. There is only one storage class that I've been given here, which is the K8S default storage. So we'll put that in there. And we shouldn't need a default class because we only have one. So let's quit that. Okay, so what do I do now? Well, all I do is just apply this YAML. So kubectl apply-f simplecluster.yaml. And hopefully if it validates, it'll tell me, yes, excellent. So the Tanzu Kubernetes Cluster simple cluster has been created. So if I do kubectl get tkc, great. What it's showing me is that I have a simple cluster. It has 1 control plane nodes, 3 worker nodes. Remember, I specified I wanted 117, so it's picked the latest 117 that it has, and it is in a creating phase. Excellent. Well, that's great to hear. So I guess I'm just going to need to just wait until it's finished creating, and then I can go back to the documentation and figure out how to log into this cluster that I just created. Now, okay, let's see if I can get any more information on this. Let's try describe TKC. Ah, interesting. Now, this does look like quite a lot of information. All right, it looks like I have VMs that are being created and some status about those. Then I have Kubernetes node status for those VMs, which I guess it's going to tell me here. Then I have various add-ons that are going to be installed, and again, it's going to give me the status on those. Let's see. Now, is this all correct? Yes, I picked Antrea. This is all the information that I entered into my configuration, and that just looks like a bunch of guff. Okay, I'm just going to wait until this is installed, and then I'm going to start playing with it. All right, I've come back with a cup of tea, and I hope that my Tanzu Kubernetes cluster is at least on its way to being created. Aha, that looks good. That looks like everything is ready. And here's the description of all the different versions of all the things that have been applied. Cool. All right, that looks like we actually have something. Now, before I move on and we connect to this, I do want to show you quickly some of the other things that you can look at while you're logged into the supervisor cluster to give you a bit more information. So the way that we stand up the Tanzu Kubernetes clusters is using Cluster API. And Cluster API has a bunch of CRDs, custom resource definitions associated with it, and you can explore the Tanzu Kubernetes cluster definition in more depth by looking at those CRDs. Now, those CRDs are automatically created out of the YAML that you defined. So let me just show you. So if we do kubectl get machines, you can see the machines. These are Cluster API machines. We can look at virtual machines. These are the actual definitions, the Kubernetes definitions of the virtual machines that were created. So if I describe those, we'll see there's actually quite a bit of information about the virtual machines. You can see the power state, the networks that they're on. It doesn't show you how big they are, but we can have a look at the virtual machine classes to see that. So if I do kubectl describe virtual machine classes, there's quite a few of these. Now the one that we care about was called best effort small. So here's best effort small. So it's showing 2 CPUs, 4 gigabytes of memory. So this is just one way to get a little bit more information about, and you can also do, there's a kubectl describe clusters. That's again the cluster API cluster definition gives you more information about the cluster. So none of that is necessary, but if you're interested in cluster API and how some of this is working behind the scenes, you can look at that. Now let's just have a quick look at what the vSphere admin was seeing during that period. Now, but given that I'm on the front-end network, I can't see my vSphere, so I'm going to switch back to my home lab network, and I should then be able to see vSphere. Okay. So let's go and look at the hosts and clusters view and see what we can see. Namespaces, test cluster. You see there's simple cluster, which is the Kubernetes cluster that we just created. And look at that. There are the nodes, the control plane node and the 3 worker nodes that were created. Now, as a vSphere admin, this should all be pretty comfortable to me. They're all just VMs like any other VM. It mentions that it's being managed by a particular service. And as you can see here, the hardware config is exactly what we requested, which is the best effort small, which is that it has 2 CPUs, 4 gigabytes of memory, and given that it's best effort, the memory will not be reserved. And yes, reservation 0. And the IP addresses that each of these has. Now you see these nodes have IP addresses on the workload network, 10.13, 10.14, 10.16, and 10.15. And DRS has just allocated these nodes to whatever host it deems necessary. These can be vMotioned around. If we lose a host, they'll be restarted through vSphere HA. So these VMs are all managed in the way that you would expect them to be managed in vSphere. So let's skip back out of the vSphere admin view, go back to our front-end network, and back to our Kubernetes Cluster Admin view. So we've created a Tanzu Kubernetes cluster. Now, if you recall from the documentation, wherever that is, yes, the next thing that we want to do is to log into this. Connect to a Tanzu Kubernetes cluster. Great. Now, given that we are a vCenter single sign-on user, this is the information for us. Okay, so we've already logged in once to the supervisor cluster control plane. Now this is telling us how to log into the Tanzu Kubernetes cluster control plane. All right, so what we'll do is we will copy the information that we previously had. So the login information that we did previously. Now let's add this to a script so that we can run it easily. Login K8S admin.sh. Okay, and then we'll do we'll add in the use context. Yes, we'll add that line in too, just to make that simpler. All right. Excellent. Okay, so that script now is good for logging me into my supervisor cluster. So actually, let's copy that. Login K8S admin.sh. Okay, so let's edit that. Okay, so now there's some extra parameters that that it was telling us to use. Okay, so --Tanzu Kubernetes cluster name and --Tanzu Kubernetes cluster namespace. Okay. So let's add those in to this line. Okay, so --Tanzu Kubernetes cluster name is simple cluster and namespace is test cluster. And then I think we're going to want to use a different context. So I am going to delete that for now, and we'll add the context that we want when we log in. Okay, so let's try logging in to this Tanzu Kubernetes cluster. So login K8S admin simple cluster. So I'm going to use the same password that I used previously. Aha! Now you actually see there, simple cluster is a new context that we can use. Okay, so if I go back in and edit my script to log into simple cluster, and then just do that, switch to context simple cluster. Cool. So can I see the nodes? Yes, I can. Excellent. So now logged in to my Tanzu Kubernetes cluster as a Kubernetes Cluster Admin. Now, if we look here at the roles, the cluster roles, you see there's a lot of cluster roles that are already created. Now, what is a cluster role? So the cluster role defines certain things that you can do to Kubernetes objects that are cluster scoped. So previously I mentioned that the vSphere single sign-on is integrated all the way through. And this is an illustration of that. So as a Kubernetes cluster admin, I was previously granted an edit role when my namespace was set up. And that edit role now manifests itself here as this edit cluster role. So if I describe role, if I describe cluster role edit, this basically explains everything that I can do. Let me make this a little bit bigger so we can see it more clearly. This shows everything that I can do as a cluster admin to cluster scoped objects within this cluster. There's a lot more that can be said about cluster roles, pod security policies, and all the other bits and pieces that we're going to be getting into when it comes to the topic of how a Kubernetes cluster admin actually manages the cluster. But that's going to be the topic for the next video. So hopefully this was informative and enjoyable, and I'll see you next time, and we'll start looking at how the Kubernetes cluster admin can start to delegate responsibility to developers to start to interact with the cluster. And then we'll do all sorts of sanity checks as well, making sure that we can create pods and create deployments and create persistent volumes and all those good things. So join me in the next video, and we'll do some of that.